This is 1.1, applying properties of real numbers, and we'll just be mainly covering the notes and stuff, and we'll be doing examples in class. So, the first thing is just like some definitions or some key concepts that would be beneficial to know. So we're going to be looking at real numbers. So we have two types of real numbers, or two big categories that they fall under. The first one is rational numbers. And so for this, they are written as quotients of integers, or they are decimals which terminate or repeat. So some examples of that would be like 1/2 or 0.5, and then we have negative 1/3 or negative 0.333 repeating. Okay, that just keeps on going. And then within the rational numbers, okay, we have integers. Okay, which basically these are just positive or negative whole numbers, essentially. So some examples. You have -2, 7, -5, 4. Okay, any number you can think of that isn't a decimal basically is this. Now, the reason these all fall under rational numbers is because I could have the decimal -2.0 or whatever, and because I have the 0.0 afterwards, it's still considering a decimal, which would terminate, and so it's still a rational number. And then inside the integers, which is inside the rationals, we have whole numbers, okay, which are basically positive numbers and 0. Okay, so the number 0 is considered a whole number. Basically, these just aren't negative, so that's why they're underneath the integers. So 0, 2, 10, 100, okay, all of those would be positive whole numbers, okay, or whole numbers, which are positive, okay, and then they go inside the integers, and then the integers go inside the rationals, which is the overarching set of those numbers. Now, within our real numbers, we also have irrational numbers. Okay, and irrational numbers, basically, it's the opposite of what the definition for rational is, but they cannot be written as quotients of integers or decimals which terminate or repeat. Okay, so some examples of irrational numbers are the square root of 2, okay, which, just in case you need to know, is approximately 1.414. Pi, okay, which we know is 3.14, and so on. And there's some other ones. Okay, another one would be E, which is like 2.7, something like that. But it's about 2. So those are examples of irrational numbers. And so we could graph all these numbers on a number line and approximate them and all of that. But if we decide to do that, that will be in class. So we have some major properties of addition and multiplication, which I hope that you've heard before, but that's not a guarantee. Find what color I want to use. All right, so properties of addition and multiplication. So for this, we are going to say let A, B, and C be real numbers. Okay, so they're either rational or irrational. Okay, for the most part, we'll be dealing with rational, but they could be irrational. Okay, and I'm going to make a table here. So we're going to need 3 columns. So the property, and then what it is for addition, and then for multiplication. All right, so the first one is going to be called closure. So this is basically just that A plus B is a real number. Okay. And then for multiplication, it would be that A times B is a real number. So that's the first one. That one's called closure. The next one is commutative. So this says that for addition, A plus B is equal to B plus A. And then for multiplication, it says that A times B is equal to B times A. So the way I like to remember this one, if you struggle to remember the names and what they actually go with, okay, is that commutative, it kind of sounds like your commute to school every day. So A is your house and B is school. So it's the same distance for you to go, or the same for you to go from home to school and then from school back to home. Okay, so that's kind of how I like to think of it there. And maybe that'll be a little trick that can help you remember, because you are responsible to know these and to be able to label what's what on a quiz or a test. Next is associative, which then says that in parentheses A plus B, close parentheses, plus C is equal to A plus parentheses B plus C, close parentheses. And then for multiplication, you have A times B in parentheses times C is equal to A times parentheses B times C. And then we have the identity, okay, which is as it sounds, okay. We have A plus something that wants to give us A because we want to keep its identity. So for addition, that would be to add 0, and that's just equal to A. Or we could write it as 0 plus A is equal to A. And then for multiplication, A times what gives us A? Well, for multiplication, that would be A times 1 is equal to A, or 1 times A is equal to A. And the last one that's specific here is inverse. So this is A plus parentheses negative A is equal to 0. Okay, so inverses cancel each other, so you should be left with 0. For addition, for multiplication though, the inverse would be A times 1 over A. Okay, so inverse doesn't necessarily mean negative. It could also mean multiplying by the opposite, okay, in this case, which is equal to 1. So A is not equal to 0 there because it can't divide by 0. So then a property that it uses both of these, which I know you've heard of before, but it's the distributive property. Okay, in this one you have A times B plus C is equal to A times B plus A times C. Okay, or the other way you could write it, which it's a lot weirder to write it this way, but you still can do it, is A plus B, or sorry, wow, I can't talk. B plus C times A is equal to BA plus CA. Okay, so these are big properties. You need to memorize these. You have to know them. But we'll actually use them in the examples and stuff moving forward. Just a couple more things here and we'll be done with that. So technically speaking, in math, there is no such thing as subtraction and division. They're just terms used to help us understand what we are actually doing, or just to make our lives easier when we're talking about it and thinking about it. But ultimately, subtraction is really just adding the inverse. So we say that B has an additive inverse of negative B. Okay, so then, for example, so that you can see how that works, A minus B is equal to A plus negative B. Okay, so this is really what's happening. Okay, we're adding the inverse, okay, but we just say we're subtracting. And then division is really just multiplying by the inverse, okay, or reciprocal, as some people like to call it, given that the number is non-zero. So we say B has a multiplicative inverse of 1 over B. Okay, so then the example of this, A divided by B is the same thing as A times 1 over B, given that B is not equal to 0. And then the last definition here, which you should have seen previously in your science classes, because I know you have to do this there, but that is unit analysis. So this is essentially when solving, or why this is important, I should say, when solving real-life problems, it is important to check units to ensure calculations make sense. All right, so just kind of as an example of what that involves, okay, if you work some number of hours and you make some amount of money, so let's just say really quick, and just to give you guys a heads up of what this is, okay, you work 5 hours and make $50, okay, how much do you make per hour? Okay, I'd like you guys to try to set this up. This is supposed to be hour. Okay, I would like you guys to try to set this up, and we will go over it in class as one of our examples. Okay, but see if you can set it up and figure out what it is of your rate per hour. Sorry this video is a little longer than I had planned for it to be. I'm going to try to keep them about 15 minutes or under. But since this is the first one, just kind of trying to adjust and get ready. But that is all for this. We'll do examples in class and have time to work on problems as well.